Okay, so once again, hello everyone. So welcome back. We are here to revise ionic and covalent bonding. Now, the previous time we went through atomic structure and ions already. Okay, but we will do a recap of ions today as well. Now, this is really the most important and fundamental lesson in chemistry. So I would strongly encourage everyone here to actually rewatch this video multiple times in full until you understand the concept behind it. The keyword here is concept. It's not about memory work. You need to understand the concept, why things lose electrons, why things might gain electrons, and so on. So the keyword today really is about understanding why. Why do things do different things with their electrons? Okay, so we are really going to start with the first question, as you can see on the screen, which is to explain how and why magnesium chloride is formed from its atoms. So the first step really is to figure out magnesium chloride. What is magnesium chloride? Well, magnesium chloride clearly is formed from the elements magnesium and chlorine. So you will look for these elements in the periodic table. Magnesium is a metal. It's actually in group 2. And group 2 elements are all metals. On the other hand, chlorine is group 70. So it's a non-metal. So this is a classic combination of a metal and non-metal. Therefore, this must be an ionic compound. Metal plus non-metal forms ionic compound. And we will see why in a very, very short while. So from the periodic table alone, you should be able to deduce that it's a metal plus non-metal. So now let's figure out. I have magnesium. What is magnesium like as an atom? So I look in the periodic table for magnesium. I realize that magnesium, Mg, has 12 electrons. 12 electrons means 2, 8, 2. First shell, 2 electrons. Second shell, 8 electrons. Third, valence, outermost shell, 2 electrons, which makes sense. Because magnesium is from group 2, it should have 2 valence electrons. So now that you have written 2, 8, 2 out, it should help you, because it makes you realize that magnesium is not going to be stable. Magnesium will react, in this case with chlorine. So when magnesium reacts, what does it do? When magnesium reacts, it will lose the 2 valence electrons. It will lose 2 valence electrons, meaning the outermost shell, the 2 electrons, will be lost. Electrons are negative. If you lose the electron, you lose negativity. You become positive. So because you have lost 2 electrons, it forms the 2 plus charge. So we call this the Mg2 plus ion. Ion refers to a particle which is charged. Okay? So up to this stage, I've actually explained how magnesium reacts. So when I'm asking for the how, what I'm referring to is whether it loses or gains electrons. In this case, magnesium loses 2 valence electrons. Let's add on to answer the why. Why does it lose 2 valence electrons? Why doesn't it lose just 1? Why doesn't it lose more than 2? So of course, the idea is, after you have lost 2 valence electrons, you now have 2, 8 in the ion. So the electronic configuration of Mg2 plus is 2, 8. The idea behind 2, 8 is that it's stable. It's stable because it has a fully filled outermost shell. Okay? So because it has a fully filled outermost shell, it makes it stable. And this is the why. The reason why it loses 2 is so as to achieve a fully filled outermost shell, which makes the ion stable. Okay? So now we have done magnesium. Magnesium loses 2 valence electrons and it forms Mg2 plus. Now we will move on to chlorine. So again, we do the same thing. We go to the periodic table and we find chlorine. Chlorine is in group 17. Cl is in group 17 and it has 17 electrons. If it has 17 electrons, what is the electronic configuration of the chlorine atom? First shell, 2. Second shell, 8. Valence shell, 7. 2, 8, 7. Which makes sense again, because it's in group 17. Group 17 elements have 7 valence electrons. So once you realize it's 2, 8, 7, and you have written it out, and then you realize in order to achieve a fully filled outermost shell, it gains 1 valence electron. Okay, so chlorine gains 1 valence electron. Now, when that happens, you are gaining negative electrons. Electrons negative. So when you are gaining the electrons, you must take note that it forms a negative ion. So it's a Cl minus ion. From 287, you gain 1 electron, it becomes 288. All right? And the reasoning is the same. It will gain 1 valence electron so that you achieve a fully filled outermost shell, which makes it stable. So the idea is stability in chemistry very often is due to the fully filled outermost shell. Okay, so up to this stage, I've fully explained how magnesium and chlorine react. The last part is something that perhaps you have never thought of before. Now that you have Mg2 plus and Cl minus ions, they are charged. When you look at the charge, you realize that one is positive and one is negative. That makes sense. But now that you know it's positive and negative, what can you say about the forces between them? If they are positive and negative, they must be attracted to each other. Right? Positive attracts negative. Opposites attract. These forces are known as strong electrostatic forces of attraction. Between ions. So these forces of attraction are strong. They require a lot of energy in order to overcome them. The meaning of the word electrostatic means the positive and negative attract. Opposites attract. That's called electrostatic. Okay, so these are strong electrostatic forces of attraction between ions. And once they attract to each other, what do they form? They form magnesium chloride. Magnesium chloride is MgCl2. Why is it Cl2? You can see from just the numbers that you have written, magnesium loses 2, chlorine gains 1. The idea is, if magnesium can lose 2 electrons, but chlorine only gains 1, this means that there must have been 2 chlorines in the compound, right? You cannot have electrons that have gone missing. You cannot have electrons which have suddenly appeared in excess, okay? So the idea is Mg2 plus, the plus charge must be balanced out by the negative charge. Mg2 plus is double positive. Cl minus is a single negative. Therefore, you must have 2 Cl minus to balance out 1 Mg2 plus. All right, so the formula is MgCl2. And this will be crucial later on. Now, these words that you have written will be crucial in drawing the dot and cross diagrams. So the next section that we're going to move on to is how to draw the dot and cross diagrams for an ionic compound. So we're going to start with the compound that you have just written, which is magnesium chloride. So again, if you are asked to draw the dot and cross diagram for magnesium chloride, you first go to the periodic table and find their chemical symbols. Beyond their chemical symbols, you should also try to work out which groups they are from, because the group number will tell you how many valence electrons they have. Magnesium is in group 2, 2 valence electrons. Chlorine, group 17, 7 valence electrons. Once you have worked out the valence electrons, you can immediately work out the charges that it will form on its ions. Just now we said magnesium loses 2 valence electrons. So magnesium forms Mg2+. Chlorine gains 1 valence electron. Gains 1 electron. Electron is negative, so it's minus. And so the formula, as we said, the positive and negative have to balance each other out and cancel each other out. Therefore, it has to be MgCl2. Okay, 2 times of the Cl minus to balance out the positive charge on the magnesium ion. Now, this formula is important because you need to know how many Cl minus to draw inside the dot and cross diagrams. Next, after doing that, you have to work out, okay, just now we have worked out Mg2 plus was originally 2A2. Then you lose the 2, becomes 2A, right? So this is my working. In reality, we have to draw 2,8, right? So I'm just showing you originally is 282, you lose 2, so it becomes 2,8. Similarly, Cl minus, originally is 287, but we gain 1, so it becomes 288. All right, so this is my working, my thought process. Of course, in the exam, you will just go straight to the drawing, 28, 288. So now we're going to draw. We draw Mg2 plus. Mg2 plus is 28. So this is Mg2 plus with a 2,8 electronic configuration. And then we move to Cl, 288. Remember this dot and cross. So if I've used dots to represent the electrons on magnesium, chlorine must be a cross. 2, I use crosses now. So 2, 8, and then another 8. But this is where you have to be careful. You know that Cl minus had gained 1 electron. That 1 electron gained is from a metal. It's from another element. So the electron gained did not belong to chlorine. And therefore, that electron which is gained has to be in a different symbol, the dot. So this is Cl minus. And now don't forget the last step. You have worked out that the formula is MgCl2 with 2 Cl minus. So you must reflect the 2. The 2 is labeled in front of the ion. In front of the ion, which is actually 2. So in this case, Cl minus, there are 2 of it. So we put the 2 outside the square bracket for Cl minus. So importantly, when drawing dot and cross diagram for ionic compound, the first step is you really need to work out the charges so that you can work out the formula. That's the first step. The second step is look at the periodic table and really work out what are the electronic configurations of the ions so that you can draw the electrons correctly into shells. Finally, you need to be mindful of some of the common mistakes that students will make. Some common mistakes I've seen is the lack of the square bracket and the charge. You must have square brackets and the charge. Some students have put the square bracket but forgot to put the charge. You need to indicate whether it's plus or minus. The next thing you must indicate, of course, is the electron which is gained by the non-metal. So like chlorine gain electron, that must be showing a different symbol. Okay? Different symbol for the electron gained. Finally, please remember to also include how many of the ion you have. So if you have 1 Mg2 plus, 2 Cl minus, then you must write 2 outside the square bracket for the Cl minus. Okay, so this is how you do the dot and cross diagram for magnesium chloride. So the dot and cross diagram is usually worth 2 marks. The explanation, how and why magnesium chloride is formed, is worth 3 marks. So you can imagine being able to explain is 3 marks, being able to draw is 2 marks. So that's 5 marks already. All right, so it's something that we need to be able to do and apply. So right now, instead of me going on, can I encourage all of us to work on the dot and cross diagrams for the next three ionic compounds. You can tell they are ionic compounds because they all have a metal and a non-metal. So calcium is a metal, fluorine is a non-metal. Metal plus non-metal forms ionic compound like this. Okay, sodium, metal, oxygen, non-metal. So metal plus non-metal, ionic compound, where one thing loses electron, the other thing gains electron. Aluminium, also a metal. Oxygen, non-metal. So aluminium loses electrons, oxygen gains electrons. Ionic compound. So ionic compounds consist of metal, non-metal, and it involves losing and gaining electrons. All right. So now let's try drawing the dot and cross diagrams for calcium fluoride, sodium oxide, and aluminum oxide. For those watching the video, you can pause the video and do it. For those on the Zoom meeting right now, I will also pause the recording. Please draw the dot and cross diagrams. And once you have finished the dot and cross diagrams, please send them to me via WhatsApp so that I can take a look at whether your answers are correct or wrong. All right. Okay, so I hope you have had some time to try the dot and cross diagrams. For those of you who are just watching this video, please try the dot and cross diagrams and let me or your chemistry teachers take a look at it when you go back to school. All right. Now, we have just covered ionic compounds. So magnesium chloride is an ionic compound. Calcium fluoride, sodium oxide, aluminum oxide, they are all ionic compounds. You can recognize ionic compounds based on the fact that it contains one metal and one non-metal. Whenever you have metal plus non-metal, it's ionic, like this. And in ionic compounds, what you have are the ions, which are formed when the atoms lose or gain electrons. So the idea here is metal plus non-metal, lose and gain electron. So in case you wanted to write it down, it must be metal plus non-metal, lose and gain of electrons. These are the two important characteristics, okay, that is behind ionic bonding. So all these compounds here, they involve metal plus non-metal, they involve loss and gain of electrons. So now, if you look at the periodic table, yes, we do have a lot of metals. But then we realize, amongst all the common chemicals that we know, we also know of compounds which are made up of only non-metals. A good example will be carbon dioxide. Carbon dioxide, I'm sure you can tell me, is a common gas around you. CO2. CO2, carbon dioxide, is made up of carbon and oxygen. Carbon is a non-metal. Oxygen, also non-metal. You have two non-metals combined, bonded together to form a covalent molecule. So now, how do I explain how carbon and oxygen come together based on their electrons? So just now, we had metal and non-metal. That one loses and gains electrons. Now that we have both non-metals, carbon and oxygen, what do? Instead of losing and gaining, what happens is carbon. The carbon atom, if you look in the periodic table, has 6 electrons. 6 electrons is 2, 4. Obviously, this is not stable because the outermost shell only has 4 electrons. It's not fully filled outermost shell. So now what would you do? Carbon cannot lose, cannot gain electrons with oxygen because they are both non-metals. Only metals can lose electrons. Carbon can't. But carbon can do this. Carbon can share. So the carbon atom shares electrons. The question is, how many? So it shares electrons with 2 oxygen atoms. I know it's 2 oxygen atoms because the formula is CO2. CO2 means 2 oxygen. Each oxygen is 2, 6. Right? when you share the valence electrons, it forms a CO2 molecule. So this word molecule tells you it has to be covalent. Sharing of electrons is called molecule. All right. Just now was ions. Now covalent bonding, molecule. So molecule means a particle that is formed by the sharing of electrons. So the carbon atom, which is 2,4, shares electrons with 2 oxygen atoms, 2,6, right, to form a CO2 molecule. Now, what is the purpose of bonding and sharing electrons? The purpose, of course, is so that all the atoms, the carbon and the oxygen atoms, have a fully filled outermost shell. So the reason why they bond together is the same. They share electrons such that all the atoms can achieve a fully filled outermost shell, which of course makes the atoms now stable inside the molecule. Okay? So this is the basis, the foundation of covalent bonding, the sharing of electrons between two non-metals. Okay? So I've used carbon dioxide as an example, but you realize that, hey, actually there are a lot of common substances, common chemicals around us which contain two non-metals. Okay, so carbon dioxide is a good example. Water is another one. If you think about it, water is H2O, hydrogen, oxygen. Hydrogen is a non-metal, oxygen is a non-metal as well. So H2O is also molecular, molecules. Okay, so whenever you see this word molecule means covalent bonding, sharing of electrons. So now how do I draw CO2's dot and cross diagram? So the concept is the same. First, you need to know that, okay, it's two non-metals, carbon and oxygen. If it's non-metal, it's covalent. It's sharing. How do you show sharing? So now let me demonstrate. To show sharing, we know that, okay, the shells must overlap. Let's overlap the shells. So I draw the shells first. I don't even write any electrons yet. I show the overlapping shells. Overlapping of shells tells you it's covalent bonding, where there is sharing of electrons. Okay? So this is CO2. I overlap the shell first. You notice that I have placed carbon in the middle. The element in the middle must be the one that has less of it in the molecule. So if you look at the formula, CO2, there is 1 carbon, 2 oxygen. Therefore, the carbon goes to the middle. Because carbon only got 1, oxygen you have 2. All right? Next, once you have done that, you know carbon is in the middle, oxygen is at the side. Then you think, okay, oxygen is 2,6. Think about the atoms at the side. Oxygen is at the side. Oxygen, 2,6. 2,6 means you need 2 more electrons. Right? Because you have 6 valence electrons, it needs 2 more electrons. So it shares 2 electrons with carbon. What does sharing 2 electrons mean? It means this. When you share 2 electrons, you will have 1 dot, 1 cross, 1 dot, 1 cross. Because the idea is, if I share 2 electrons with you, you will share 2 electrons back with me. I share 2 of mine with you, you share 2 of yours with me. So dot, cross, mine, yours, yours. Okay? So same for the other side. Dot, cross. You have to get this correct first. This is the first mark. Then the second mark comes in when you realize what is the purpose, the function of sharing. The purpose of the sharing is to achieve fully filled outermost shell. Fully filled outermost shell means must have 8s for oxygen and carbon. So now let's look at oxygen. Oxygen, so far I've drawn dot, cross, 4 already. Meaning, need to have 4 more outside. 4 more outside. Cos 4 plus 4 equals 8. You must ensure that the outermost shell you have drawn 8. Now let's look at the middle carbon. The middle carbon, on the left, there's dot, cross, 4. On the right, dot, cross, 4. 4 plus 4 equals 8. So the carbon already has 8 in the middle. Okay? So you need to ensure that each atom inside the molecule has a fully filled outermost shell. Now, let's say the question wanted you to show all electrons. Is this all electrons? Are these all the electrons that are inside carbon dioxide? The answer, of course, is no. You know that carbon has 2 shells. So far, you only drew the outer shell, meaning there is still 1 more shell inside it. The 1 more shell inside it must have 2 electrons. Similarly, oxygen. Oxygen has 2 shells. You have only drawn the outermost shell, which is the one sharing the electrons. The inner shell must still be drawn in. So this is called showing all electrons. So like I said again, it depends on the question. The question will tell you to show all electrons or show outer electrons. So you must read the instruction. If the question asks you to show all electrons, do not forget the first shell that's inside it. Okay, so this is the dot and cross diagram for carbon dioxide, which has covalent bonding because it contains 2 nonmetals. Now let's move on to the next one, which is water. Water is H2O. I'm sure you're familiar with this. But based on the chemical formula, you can tell H2O means it has 2 H, 1 O. So how do you draw the dot and cross? Again, you know that the shells must overlap. Right? The shells must overlap because it's covalent bonding between nonmetals, sharing of electrons. The element that goes into the middle must be oxygen because there's only 1 oxygen and 2 hydrogens in H2O. The one that has smaller number goes into the middle. By smaller number, I mean in the chemical formula H2O, I have less oxygen. So the one with less goes into the middle. Next, we have to decide how many electrons will hydrogen share. For hydrogen, it's simple. Because if you look in the periodic table, hydrogen only has 1 electron. If you only have 1 electron, the only thing that you could do is to share 1. So you notice, if I share 1, it's dot and cross. Why dot and cross? Because hydrogen shares 1 with oxygen. Oxygen will share 1 with hydrogen. 1 dot, 1 cross. That's called sharing. Okay? Now, we need to ensure that every single atom in H2O has a fully filled outermost shell. Then let's think. Hydrogen, 1 electron in the first shell. First shell holds a maximum of 2 electrons only. So for the hydrogen, having the dot and cross already has 2 electrons. 2 electrons means first shell full. So for hydrogen, because it only has first shell, it's already full. So hydrogen, do we still need to add electrons outside? No. Hydrogen will never ever have electrons outside once it has shared. So hydrogen will be just like that. Good enough. But for oxygen, oxygen is the second shell. Outer shell is the second shell. Second shell can hold a maximum of 8. So far, I've drawn 1 dot, 1 cross, 1 dot, 1 cross. So far, Mr. So has drawn 4 electrons. Therefore, I need to draw 4 more outside the oxygen. And that makes a total of 8 electrons in the outer shell. So again, what I've done for H2O is to draw the dot and cross diagram showing the outer shell electrons. If I wanted to show the inner shell electrons, if I want to show all the electrons, I need to draw the inner shell. The inner shell is the first shell with 2 electrons. The first shell's electrons are not shared. They are never shared for oxygen. you share the outer shell. You do not share the inner shell. So the inner shell is just as it is, 2 electrons. So again, I'm showing all electrons. Okay, so this is how we draw the dot and cross diagrams for covalent molecules. We basically work out it's covalent because they are all non-metals. Then second step, we overlap the shells. The element in the middle must be the one that has fewer number of it in the molecule. After that, we decide the atom at the side, how many more electrons does it need? The number of electrons it needs is the number of electrons it shares. So oxygen needs 2 electrons, so you share 2 electrons. Share 2 means dot cross, dot cross. Okay, important. Okay, finally, make sure that every single atom has a fully filled outermost shell. Make sure you count and make sure it adds up to the fully filled outermost shell number. Right? So now let's practice with part 3, ammonia. I've given you the formula NH3. And part 4, nitrogen, which is N2. Please draw the dot and cross diagrams, and once you're done, take a picture of it and send it to me so that I can check immediately. Okay, so maybe we look at one more example before we move on to the properties, which is the nitrogen molecule. Now, nitrogen molecule looks like this. There are 2 nitrogens, so there's nothing in the center, right? It's just 2 nitrogens. But you need to decide, nitrogen has 7 electrons, so it's 2, 5. So if it's 2, 5, there are 5 electrons in the outermost shell. So how do you go from 5 to 8? To go from 5 to 8, you need 3 more electrons, right? If you need 3 more electrons, it shares 3 electrons. All right? So what does sharing 3 electrons look like? Dot, cross, dot, cross, dot, cross. This is sharing 3. All right? 3 pairs of dots and cross. A total of 6 in the middle. So now that there are 6 in the middle, you know you need 2 more. Okay? So this is how we draw nitrogen molecule, N2. Okay? Now, of course, it's not showing all the electrons yet. So how do you show the inner shell electrons? We just have to draw the 2 inner shell electrons for each of the nitrogen atoms. Okay, let's N2. All right. So now we move on to the properties of the ionic compounds and the covalent substances. All right, so we just quickly run through the properties. So we have to get ready to answer them. The idea is you must be able to explain the properties of the ionic and covalent substances. Okay. So let's just draw a simple table, a very simple and short table, where we have ionic, covalent. Now, covalent is usually called simple molecular structure. So now we are going to discuss just 3 properties. The first one is melting point. The second one is electrical conductivity. You need to know how to describe the property. You also need to know how to explain the property. All right, so let's start. So ionic compounds have a high melting point. So the high melting point means that it melts at a very high temperature. So this melts at more than 500 degrees Celsius. Okay, so how do you explain that ionic compounds have a high melting point? We explain ionic compounds have a high melting point in terms of the forces of attraction. Because you have learned from physics, from science, that when you melt something, you form a liquid. To form a liquid, you have to overcome the forces of attraction. So in ionic compounds, just now we saw with magnesium chloride, we know that the forces of attraction are called strong electrostatic forces of attraction between ions. So there are strong electrostatic forces of attraction between the ions in magnesium chloride, in calcium fluoride, sodium oxide, and so on. So long as a metal and non-metal is ionic, there are strong electrostatic forces of attraction between the ions, which require a lot of energy to overcome. So you need to supply a lot of heat energy to overcome these strong electrostatic forces of attraction between the ions. On the other hand, for simple molecules like CO2, H2O, carbon dioxide, and water, right? They are covalent. They are simple molecular in structure because they have two nonmetals. So if you have two nonmetals, the melting point and also the boiling points are low. So if you think about it, carbon dioxide is a gas. If it's a gas, the boiling point is low. So why is it that simple molecules will have low melting points and boiling points? We go back to the forces of attraction. This is where you need to know. There are weak intermolecular forces of attraction. Okay, so between the CO2 molecules, there are weak intermolecular forces of attraction. You can see this word, intermolecular means between the molecules. So it really only applies to things which have simple molecular structures, like CO2, H2O, NH3. So basically the covalent substances that we worked on just now. The next keyword here is they are weak forces of attraction, right? So because they are weak, they will require a small amount of energy or little energy to overcome. If the forces are weak, you don't need so much energy to overcome them. So the amount of energy is small or little. So you can see for melting point, we go for the forces of attraction. You must talk about the forces of attraction when you are asked to explain melting points. Now, we will go on to conducting electricity or electrical conductivity. So, what does electricity really mean? So if you think about Sec 2 science, you have learned electricity. You have learned that, okay, you connect a battery with wires to a light bulb, it lights up. The light bulb lights up because there's an electrical current. Electrical current is a flow of charge. So the idea is charge flows. Charge must be free to move. So when you discuss electrical conductivity, the main concept here is, firstly, do these things have charge? Secondly, do they move freely? So if you look at ionic compounds, just now we did magnesium chloride. Magnesium chloride contains Mg2+, Cl-. So the magnesium ion has a charge. The Cl- also has a charge. But the issue is, are they free to move? So for ionic compounds, they do not conduct in the solid state. So magnesium chloride, if it's a solid, it will not conduct electricity. The light bulb doesn't light up if you connect it to a battery and a light bulb. But it will conduct in the molten or aqueous states. So what do these words mean? Molten or aqueous? Molten means melted. I heat it up, I melted it to form a liquid. So the state symbol is liquid. Aqueous, you know the state symbol is AQ. Aqueous just means dissolved in water. So ionic compounds are quite special because ionic compounds, they do not conduct in the solid state, but they will conduct electricity in the molten and aqueous states. Why? So there must be a difference between solid and molten aqueous. In the solid state, the ions are not free to move. So that means the particles cannot move freely as they like. So the ions are not free to move. But why? This is because the ions in a solid state are held in fixed positions by strong electrostatic forces of attraction between the ions. So you have learned before, in a solid state, the particles are held in fixed positions. So same here, ions are held in fixed positions by strong electrostatic forces of attraction between the ions. So in a solid state, they cannot move freely. But in the molten or aqueous states, the ions can move freely to conduct electricity. Okay, so you have learned before, right? Particles in a liquid, they slide over one another easily. So it tells you that, hey, ions in the molten state, they can move freely. They can slide past one another. Okay, so in a solid state, cannot, because it's fixed positions, not free to move. But in the molten and aqueous state, free to move. That's why they can conduct electricity when they are melted or dissolved in water. So that's for ionic compounds. This is a very unique property of ionic compounds because they only conduct electricity when melted or dissolved in water. For your simple molecular structures, which means covalent substances like carbon dioxide, ammonia, they do not conduct electricity. So on their own, they will not conduct electricity. And the reason is because there are no free moving ions or electrons. So in a covalent substance, there are no free moving ions or electrons, which makes sense because a covalent substance is made up from sharing of electrons. If the electrons are shared, there are no ions to be saved, right? Ions are only formed when things lose or gain electron. Sharing will not form ions. Okay, so that's electrical conductivity and how to explain the difference between ionic and covalent substances. All right, and finally, we go to the last one, which is solubility. Whether they dissolve or not. This one don't need to know how to explain. You just need to know the property and state it. So for ionic compounds dissolve in water. So most ionic compounds dissolve in water. They are soluble in water. So for example, magnesium chloride is soluble in water. But they are insoluble in organic solvents. So organic solvents means things like oil. So magnesium chloride is insoluble in oil. You cannot dissolve the magnesium chloride in oil. On the other hand, for the covalent substances, it's the opposite. Most simple molecular substances, covalent substances, are insoluble in water. So for instance, carbon dioxide. Carbon dioxide doesn't dissolve very well. It's slightly soluble, but not very soluble in water. So covalent substances are insoluble in water, but they are soluble in organic solvents. Okay, so they are opposites. So you can really see that ionic and covalent bonding are really opposites of each other, be it in terms of what they do with the electrons, be it in terms of their properties like melting point, electrical conductivity, solubility. Okay, so these are the three physical properties of ionic and covalent substances that you must know. Okay, and for melting point and conductivity, you need to be able to explain these properties as well. So learning the explanation of the properties is very crucial. So I hope you can spend some time learning the concept and also learning the explanations. Okay, if you find it difficult to remember the explanations, it helps to write out the explanations a few times. By writing it out a few times, this table, you can draw it out and write it out a few times. It really helps with your understanding later on as well. All right. And that really brings us to the end of today's lesson on ionic and covalent bonding. How do the bonds form? How do we draw dot and cross? And finally, we ended off with how to explain the physical properties of ionic compounds and covalent substances. Okay, so please revise and rewatch this video if needed so that you are able to internalize and understand everything. All right, thank you.